vector. What's vector? So basically the opposite is the scalar and vector. And you can see here, scalar has only magnitude, and while vector has magnitude and direction. By saying that magnitude is like how strong a quantity is, like a force, and how strong the force is, while the direction tells you direction. So here's some examples here. Scalar quantities, which has length, area, volume, they don't have direction, right? So like even for length, like it's saying, okay, how long this part is, like 3 cm, it has no direction. And also things like pressure, temperature, energy, definitely it has no direction. Well, examples for vector would be something like displacement, velocity, acceleration, forces, things like that. So basically these are called the vector which has the direction. So why do we need to learn about this then? In our world is 3D. Alright, I assume you know what 3D means. Like when you go and watch a 3D movie, it looks real. Because it has 3 axes, X, Y, and Z. And that makes up our world. While what we are going to do, which is simpler, because we only learn, well, at least for these 2 years in physics, we only learn in 2D direction. So basically only X and Y axis here. So basically it's like I gave you 2 vectors, which is a green one and a blue one here, and you need to help me to find the result, which is a red one here. Alright, and it helps us to find and simplify so many problems in the physical world here. So how do we get the result then? Here we only introduce you the graphical method, which helps you to find the resultant vector. Another way is using the math way, which is using the algebra, but it won't be introduced in IGCSE physics here. So let's talk about graphical method only this time. Firstly, the ideas of vector is it has direction, right? So for vector, you can draw this kinds of arrow, which has an arrowhead and arrow tail, we say. By constructing a diagram like this, you are going to move around the vector, and so that the head here and will be sticking with the tail of the other one. And at last, you can draw the only one direction of a vector, which in blue here, to represent the result, the combination of these 2 green vector. You can also try to go for this website, and it will show you some example, and I can show you right now. So basically, you can do this. You get 2 vector. You can change the direction of them, and also the length. Be careful. The length of the arrow represent the magnitude, like how strong like a force is. So let's put this together. So say if an object here which was experiencing these 2 kinds of forces, the resultant will be same as you move these forces. Remember, you don't change the magnitude or direction. I just translate, right, by moving the arrow to the suitable position, which is here, because I want the head and tail to be sticking together. Right here, before that, the tail are sticking together here, so it's not good. So that's why you want to move it here, so that you can find the resultant, and the resultant will be same as this one. Right? I can try to show you with the simulation here, which is here. So it should be the same as this. So as long as your head and tail are sticking together, it should be always the same. Like whenever you change one of the vector, the resultant will be changing accordingly, and of course with different direction, different magnitude, things like that. So you can try to get this and get the ideas of this. Even if you try to add one more vector, say one more force is acting on the object. So let's say in this way then, what is happening is you can still sticking with the method, which is head and tail, remember, and you can always add here so that it makes head and tail, or you add here. Okay, let's say we add here, and the resultant, what do you think? The resultant should be, alright, let me guess, should be from here, because I want to use one arrow represent the ideas, right? So it will be from here to here. So let's check the answers. Should be like this. Exactly. Alright, so this is how we are going to do in terms of the ideas itself. Okay, in the next video I'm going to show you one example from the past paper, and I want you to do it with me. And please prepare yourself a protractor and also a ruler and a piece of paper, of course, and click the next part of the video and we will start to do it.